In this lesson, we are going to continue with our multi-step equations, this time having variables on both sides. To begin, I want to show you the difference between your first step when you have variables on both sides and when you just have the variables on one side, as we've been doing. So in both cases, we're drawing the line down the equal sign. When we have the variable on one side, as in our problem on the left, 3x plus 5 equals 17, the first thing we're going to do is undo that addition. So we'll do the minus 5 from both sides. This cancels, so we have 3x equals 12. When we have variables on both sides, we could do the same thing. We could get rid of that 5 first, so actually let's do that so we can compare them a little more easily. So I just do the inverse to get rid of, and that should say minus. We do the inverse to get rid of that term or to move it to the other side. So now we have 3x equals 2x plus 4. So now it's really clear the difference, because on the equation with a variable on one side we have 3x equals 12, but on the equation with the variables on both sides we have 3x equals 2x plus 4. So at this point we have to get the variables on one side, because otherwise we don't know what to divide by, because there's coefficients or numbers in front of variables on both sides. In order to do that, I want to take my variable over here, my 2x, away and move it to the other side, because that's where I still have my constant of plus 4. If I moved the 3x over, then I wouldn't have anything left on the left side, and it would give me an extra step to do, because I would have to undo one of the terms on the right to move it back to the left. So it's less work if I just take this term and move it over. What we're going to do is subtract 2 x's from both sides. We have to keep the whole term together because we're moving it to the other side. So this is where the tricky part comes in, because you're used to seeing a coefficient and a variable, and typically in this situation you would divide to solve for x by itself. But we're trying to get the 4 alone, so we're moving the entire term to the other side. So when we're taking a whole term and going over that line for the equal sign, we have to do the opposite and keep the x with it, because at this point I'm not solving for x. That'll be in the last step. I'm taking my x's and moving them together. It's like combining like terms, so you can think of it that way. But remember that if you're combining like terms across the equal sign, you have to do the opposite. Okay, so 3x minus 2x gives us just 1x left, because if I had 3 x's in my hands and I took 2 away, I would have 1x left. This canceled out, and we get x equals 4. So in this case, that was our last step, was moving that negative 2x to the other side. If we go back to our original problem, we have now a one-step equation. That cancels and equals 1, so I have 1x equals 12 divided by 3 is 4. So both of our equations have the same solution, but the equations were different in that one of them had variables on both sides of the equal sign and the other has variables on just one side. Right, so let's do another example. Actually, I don't want to do that one. Okay, so 5p minus 14 equals 8p plus 4. This is the point I would like your notes to start at if you did not start them already, but it's up to you if you're going to take notes while you watch it or if you're going to wait and take the notes at the end. But this would be the first example I would like you to have in your notes. Okay, so now our first step, as always, is to draw a line down the equal sign so we can clearly see our two different sides of the equation. So it's up to you if you want to take the constants and move them to one side, or if you want to take the variables and move them to one side. In this case, I'm going to take the variable and move it to one side. So let's do minus 8. Minus 8. Remember, you can think of it as combining like terms, but when you cross that equal sign, when you take it over this equal sign, you have to do the opposite and take the whole term. So now I will not have any variables or any p's on the right side. They're only on the left. And 5p minus 8p is negative 3p. I bring down my minus 14, keep my equal sign in the same spot, and it's equal to 4. And now this is something we know how to do very well. It's a two-step equation using don't chuck tacos at me. There's no distributing, so I don't need to distribute. There's no more like terms, unless you want to start thinking of it as these two constants are like terms, so you combine them. But again, when you're moving across that equal sign, you're doing the opposite. So you could think of it like that if that makes more sense to you. Right? And then we undo addition or subtraction first, and then we undo multiplication or division. So now we're left with 3p equals 18. And our last step, we don't want to know what negative 3p is equal to. We want to know what just p is equal to. So since negative 3 and p are being multiplied, we divide them. When we divide by negative 3 to solve and get p alone, negative 3 divided by negative 3 is 1. So we're left with p equals, and 18 divided by negative 3 is negative 6. So the only way to make this equation true is to have p equals negative 6. So that means this equation has one solution. And so far, all the equations you have done have had one solution. That is very important to note. All right, so example number 2. We have 5n plus 34 equals negative 2, parentheses, 1 minus 7n. So draw a line down your equal sign. We can see that we have variables on both sides. We have 5n here, and we have a negative 7n here. But we can also see that there are parentheses, so we need to remember to distribute first. We can't just move this negative 7n and combine it with this 5n, because there's distributing that has to happen first. So that'll be our first step. So negative 2 times 1 is negative 2. Negative 2 times negative 7 is positive 14, and we have to keep that n since we're multiplying. I keep my equal sign straight down, and then 5n plus 34. Next step, you can think of it as combining like terms across the equal sign. We need to have our variables on one side. So this time what I'm going to do is think, okay, I have 5 n's here, I have 14 n's here. It's easier for me to work with positives when I can, so if I subtract the 5n from both sides, I know that since 14 is a bigger number, 14 minus 5n will give me a positive number, whereas if I moved the 14 over to the side with the 5, I would have a negative number, which would be fine, but since I have the option, I like to keep it without negatives when I can. So I am going to choose to subtract 5n from both sides. If I have 5 n's and I take 5 n's away, I don't have any n's left. So I have 34 equals negative 2, and then 14 n's minus 5 n's gives me 9 n's left in the pile. And from there, we have a two-step equation. I have negative 2 being added to 9n, so the opposite of adding a negative 2 is adding positive 2. And you can think of this also as minus 2, so the opposite is to add 2. Remember, your goal is to get them to cancel out. That will cancel. So I have to add 2 to the other side as well to keep my equation balanced. 36 is equal to 9n, and that's positive. Last step, get n by itself. So since 9 and n are being multiplied, I will undo that by dividing by 9. That cancels out and equals just n. 36 divided by 9 is 4. So n equals 4 is my answer, and again I have one solution. This is telling me that the only way to make this true is when n is equal to 4. Then both sides of the equation will be equal. All right, the next example we're going to do will be slightly different. So we have 4m minus 4 equals 4m. Okay, this is where you have to make sure you're following all of your steps, writing out all of your work, otherwise these can get confusing at the end. Okay, so we draw a line down the equal sign. So we only have a constant on one side. We have that negative 4 is the only thing on the left. Our variables are on both sides. So we need to combine those. If you notice, they're the same exact thing. They're the same exact term. I have positive 4m and positive 4m. So when I take my 4m and I subtract it to move it to the other side, think about what I'm going to get. So 4m minus 4m is 0. It cancels out. So I bring down my negative 4. And now 4m minus 4m, if I had 4m's in my hands and I drop 4m's or someone takes 4m's, I have nothing left in my hand. So that's 0. It's not 0m, it's not 1m, just 0. The m's are all gone. Negative 4 equals 0. Does that make sense? No, negative 4 will never be the same as 0. So that means that this equation has no solution. And so you'll have no solution whenever you have two numbers that are not the same is what you're left with. So if you had like 7 equals 10, no solution. That does not make sense. They are not equal. Right, and let's do another example. So 24a minus 22 equals negative 4 parentheses 1 minus, doesn't look good, 1 minus 6a. Okay, so we see those parentheses, so our first step is, of course, to distribute. So negative 4 times 1 is negative 4. Negative 4 times negative 6a is positive 24a. And then you have 24a minus 22 equals positive 24a. So now I like to combine my like terms from opposite sides of the equal sign first. So I know that that means that I need to do the opposite to that. So 24a minus 24a cancels out. I have negative 22 equals negative 4, and then minus 24a minus 24a cancels out, so there's nothing to write there. So I'm left with negative 22 is equal to negative 4. That does not make sense, so our answer is no solution. And you can write out no solution, or you can do a circle with a slash through it. That also means no solution. So now we've seen some examples of no solution and one solution. So we have one more type of problem to do. Alright, so the next example that we're going to do is negative 2 times x plus 3 equals negative 2x minus 6. So think, what is our first step going to be looking at this equation? Hopefully you said distribute. Negative 2 times x is negative 2x. Negative 2 times positive 3 is negative 6 equals negative 2x minus 6. Alright, I'm combining my like terms, getting my variables on one side. So the opposite of negative 2x is positive 2x. And I'm doing the opposite to that whole term because I'm moving it across that equal sign. Negative 2x plus 2x is 0, so I have negative 6 equals negative 2x plus 2x is 0, so I bring down my negative 6. So this time I have a statement that is true with just numbers. Negative 6 is equal to negative 6. So that's absolutely true. They're equivalent. So that means that there are infinitely many solutions. And you can shorten that by just writing IMS, or you can do the infinity symbol. That means that any real number will work to be a solution. So you can put in negative 52, you can put it for x, you can put in 1,000,000 for x, you can put in 356 for x. Any number you put in for x will make this equation true. So that is solving equations with variables on both sides. You should have notes from this video, whether you took them as you watched them or took them after, it doesn't matter. All but that very first example that opened the video. Everything else should be in your notes. So again, it's very important that you are writing out all of your work because it will help you to follow the process and arrive at the correct answer.